In this video, we're going to look at the number puzzle from the 2022 AQA AS skeleton code. So what exactly is the program all about? This program is called NumberPuzzle. If you're familiar with the game Sudoku, that's what this program is. But if you're not familiar with Sudoku, here's how it all works. In this game, there's a 9x9 grid, and this grid can be split into 9 3x3 grids. The goal of the game is to fill each 3x3 grid with the numbers 1 to 9. Of course, no numbers in this grid can be repeated. At the same time, each row and column in the 9x9 grid must also contain numbers 1 to 9 with no repeated numbers. The user is presented with a 9x9 grid which has some boxes already filled in, and it's your goal as the user to fill in all other boxes within the grid without having numbers repeat in the same row, column, or 3x3 grid. This starts off being quite fun until you realise it starts to feel close to impossible to complete, and you just want to throw the game away and never look at a 9x9 grid ever again. Alright, let's break down this program by looking at the files. So there are 4 files with this code, the Python 3 file, then we have 3 text files. Puzzle 1, which contains data for an unsolved puzzle, as we see on the left. Puzzle 1p, which contains data for the solution to puzzle 1, which is on the right. And finally, puzzle 1s, which contains the solution to puzzle 1. Most of these text files are self-explanatory, so I recommend pausing the video here, look at the PDF file which shows text files, compare them to the grid examples in that PDF file, then work out how each text file is doing what they're doing. So, how is the code triggered? Right at the bottom of the code, you'll see these 2 lines. In its simplest explanation, these lines tell Python which subroutine we will use first, which happens to be NumberPuzzle. In a slightly more detailed explanation, name represents the file we are working in. Some Python programs use multiple Python files. The first Python file which gets the whole program started is called main. The first line is checking if the name of this file is called main. We should follow the instructions below, which just so happens to be the trigger to the subroutine NumberPuzzle, or calling the subroutine NumberPuzzle. NumberPuzzle is the largest of the subroutines in this program. It actually leads us to pretty much every other subroutine. Obviously, this screenshot you see is not the whole code for NumberPuzzle. I'm just breaking it up in different pieces to make it easy to follow, and also easy to see on the screen. Let's start by breaking down this code. First, we set a variable called finished to false. We should assume this is to trigger either a while loop or if statement later on. In the next line, we have 4 variables, puzzle grid, puzzle, answer, and solution, which are being assigned some values with the use of the subroutine ResetDataStructures. Before we carry on, let's see what ResetDataStructures is doing. As you can see, this subroutine starts with a puzzle variable which uses a for loop to create the cells for the puzzle's grid. It takes the empty string variable, which is global as it's set right at the top of the program, outside of any subroutine. It effectively takes the empty string that repeats it 81 times, which will be used to create the 9x9 grid later. A similar situation is happening with the other 3 variables. They are being used to set up a blank placeholder for each position in the grid. If you run these variables on their own and output them, you'll see they don't appear as a grid yet. That's because there'll be more code later on which will present them in the appropriate format for the user. In the very last line, you'll see those local variables are being returned, making this a function. And if you remember previously, you should know that the NumberPuzzle subroutine makes use of these variables. Let's go back there now. Alright, back in the NumberPuzzle subroutine, we now know where those variables are getting their values from. Don't worry if you don't understand their use yet. It only makes sense once you see how they're being used. Moving on, you remember I said the finished variable would use that Boolean value to trigger a while loop. Well, that's exactly what happens. Based on the naming convention alone, we can assume that finished is implying whether or not the user is done with the game. In this case, as long as they're not finished, we can start our game. The first thing that happens here is the DisplayMenu subroutine is triggered. The DisplayMenu subroutine is super easy to understand. You can probably tell it just simply outputs the menu which shows the options to the user. At this point, that's all it does. But how will the user respond? Let's go back to the NumberPuzzle subroutine. The final line of this part of the NumberPuzzle subroutine uses a variable called MenuOption and assigns a value to it. This value comes from a function called GetMenuOption. Let's go there now. So we start off by assigning an empty string value to the choice variable. Then we use a while loop to get a value from the user. The way this works is by looking for the length of the value that's inside the choice variable. In this case, it's 0 as it's empty. Then, as this is not a length of 1, the user is asked to enter a value. You might wonder why the function can't just have the input line without the while loop, and you're absolutely right that it could. However, by having the while loop, it creates a validation rule to ensure that the user only enters one character into the choice variable, as the options available on the menu are one character each, or one character long. What's interesting is the last line, which not only returns the choice local variable, so it can be used in NumberPuzzle, but it also ensures only the first character is taken. Again, another additional validation rule. Okay, now back in the NumberPuzzle subroutine, you can see just how large this is. And don't worry, the fun doesn't stop there. There's more to this subroutine that I'm not showing yet. Let's look at all this excitement now. You can see this section of the subroutine calls upon other subroutines based on whatever the user entered previously. The first option is L, which calls upon the LoadPuzzle subroutine. Let's see this now. The LoadPuzzle subroutine starts off by assigning values into puzzle grid, puzzle, answer, and solution via the use of the ResetDataStructures subroutine. Now, if you're not sure what's happening here, just go back a little as this line was explained previously. The code then asks the user to choose a puzzle to play. The user should then enter the name of the puzzle. For the files we have, you would enter puzzle 1 as that's the only puzzle we have. The next line then takes two variables, one called puzzle and one called OK. I'd imagine based on the name that OK will be a Boolean variable, but we'll find out in a moment. These variables are assigned using the LoadPuzzleFile subroutine, which requires the parameters of puzzle name and solution. These are values that are already assigned within the subroutine. Alright, let's take a look now at the LoadPuzzleFile subroutine. In LoadPuzzleFile, you can immediately see there's some exception handling going on with the use of try and except. First, we assign the value 0 to the variable line. We'll see soon what this is being used for. In the next line, we have a variable called fileIn, which will store the text file puzzle1.txt or whatever puzzle the user enters before the subroutine is called. Self_file is a variable which takes in the first line of the text file stored in fileIn. The following line ensures the entire first line is stored in cell_info. You may be familiar with the command read, which will read the entire text file. Well, read line stores the next line in the file. It also ignores any previous lines. The first time it's used, it will take the first line. The next time it's called, it will read the second line as it will no longer see the first line. And the third time, the third line is read as it no longer sees line 1 or 2, etc. As we move on, you can see that we now have a while loop in place, where it checks to see that as long as what's in cell info is not empty, it will enter each line of the puzzle, one line at a time. By using readLine, it runs through each line of the text file, then as soon as all lines have been entered, we leave the while loop, because according to readLine, there's no more lines left. The last line of the while loop changes the line we're entering values into in the puzzle. After this, we have a series of lines that do some error checking. For example, if line equals 0, well, this checks to see if the value of line is 0, because it will only be 0 if we don't enter the while loop, and we don't enter the while loop if the text file for the puzzle is empty, which is why it then outputs the message puzzle file empty. OK as a variable is then set to false, and we'll see why later. Otherwise, it's set to true, and again, we'll see why later. Finally, in the except, it outputs the message puzzle file does not exist. This is because if you enter the wrong file name, a red error message will appear because Python can't find the file, which will exit the program instead. This way, by using except, we get a more user-friendly message which won't terminate the program. Instead, it sets OK to false, and we go back to the previous subroutine. Speaking of, let's go back to the LoadPuzzle now. Up next, in LoadPuzzle, if we've got our puzzle put together, the value of OK will be true. Otherwise, it will be false. If OK is true, we'll be running the load solution function to get the solution ready, as well as the subroutine transfer a puzzle into the grid to put our puzzle into the grid. Alright, we're going to take a pause there, as I think it's enough for one video. Run through part of this code we looked at in this video and leave a comment next to each line to explain what's happening. I'll explain the rest of this code in part 2.